the next item on the agenda, which is, oh, these things. I was supposed to have that not up there. Hopefully you guys have seen this before, though. The answer of a multiplication problem is a product, right? Because we're going to start doing word problems, so we're going to have to work on like translating between English and algebra. So if in a word problem, if they say the product of two numbers, you have to know that they're telling you that there was two numbers that got multiplied, okay? For subtraction, the answer is called the difference. So if they say the difference of two numbers is something, that means they're subtracting two numbers, right? For division, the answer is called a quotient. Again, that's your clue that they tell you that two numbers were being divided, okay? And for addition, it's either the word sum or total. They're both used, like about equally, actually. So if you don't know this stuff, you should definitely write this down because you have to know this stuff, okay? So you got it? So we're going to be talking about how to translate from English into algebra. Oh, well, everybody said they were done. Words that you have to know that tell you what operation is going on in each problem. Good, how you doing? So let's start with the easiest one, right? If they say something like increased by, so if they say some number increased by 2.
That would be x plus that number.
Okay, in this case it would be x plus 2, right? Something like that. So increased by means when you're making something bigger, right? So when you're making it bigger, you're adding to it, okay? The other thing that they could say is they could say greater than.
Do you want us to write that?
You should. Right? If they say 2 greater than a number, it'd be x plus 2, same thing, okay? You got to be careful because this is not this thing, right?
Yeah.
So there's a lot of people when they see that, they're thinking that. Yeah. With word problems, it doesn't mean that, okay? So, go away. They can also say more than. 2 more than a number, x plus 2, or n plus 2, right? Doesn't matter. Sometimes with the word problems, they use n instead of x. It doesn't really matter, okay? Same idea. So this is all words that tell you where you're using addition, right? They can also actually say plus. Or they could use the ones we just learned. They could say sum or total. That tells you also that you're using addition, okay? So subtraction is the opposite. Instead of increased by, what would they say? What's the opposite of increased by?
Decrease.
Decreased by, yeah. Instead of greater than?
Less than.
Less than. And instead of more than, it's also less than. Instead of the word plus, they might use, what do you call that sign, the subtraction? Minus, right? There's another word that they sometimes use. They might say diminished by.
Never heard of it.
Yeah, I think they actually use it in our sheets. I have to see, but I've seen that. Diminished is just another word that means make smaller, reduce, okay? Reduced by is another one that you can say, right? These all tell you that you're doing subtraction. So if they say a number decreased by 3, for instance, right? A number diminished by 3, the same thing. A number reduced by 3, the same thing. The only problem here is when we're talking about this. Because let's say we're talking about, somebody tell me what number is 2 less than 7? Huh? What number is 2 less than 7?
Well,
Oh, 5. You got $7, you take 2 away, what do you have? 5. So, but if I write it like I said, if 2 less than 7, you're tempted to do this. 2 less than 7, right? But that would give you -5. That's not what we want, right? With the less than, you got to reverse the order. If it says 2 less than 7, you got to start with the 7, and then say, okay, 2 less than that would be subtracting that. So with the less than, you got to be careful because you got to flip the order, okay? And if you get confused, think about it like this. Let's say, okay, wait, 2 less than 7. If I write 2 minus 7, it gives me negative. That's not what I want, right? Okay? That's the one that's sort of the trickiest one. So now we have multiplication. Multiplication is the one there's not that many words for.
Product.
Yeah, they'll say product for the answer, good. I guess I should write down, here they could put difference, right? We kind of talked about that already. They could actually say times, right? Some number times this. Or they could say multiplied by, those are kind of obvious. There's a couple of numbers that have their own name. What word means multiplied by 2?
What's the product? Wait.
There's like one word that means you're multiplying something by 2. That would be times itself. You're in the right ballpark, but it's the wrong operation. If I say, here, let me give you, huh?
Exponent.
No. Here, listen. If you, what I say earlier, oh yeah, let's say you visit someplace in Europe. Let's say you go to France, right? And you went to France in the summer of 2013 and the summer of 2014. So when you come back after the second time, you can say, oh yeah, I've been to France. I've been to France twice. That means 2 times, right? So if it
Twice
says,
the number.
huh?
Isn't it like twice the number, right?
Yeah, you could say, but it might say like twice X, twice a number. It might say twice 10, or something like that. So twice means multiplied by 2. What's another word that means times 2? If I have $5, you have $10, right? You have twice as much as me, but you also have, yeah, good, double. And also, if it was 3 times something, you could say triple. Good. Right, so those are words that tell you they're doing multiplication, okay? There's actually a word called treble, but I don't think they use it here. Treble means it's like double but 3 times, okay? And then the last one is division. Division is the one that has like the least words for it. Sometimes they'll actually put into, like you would say 5 into 2 or something like that, or I guess more like 2 into 10, something like that. Or they might actually use the word divided by, or quotient. And there's another word. Division essentially is, think of it like a fraction. There's another word that means fraction. That's usually written like this, like What is that?
Ratio.
Ratio. So if it says something about ratio, that tells you they're doing a division, right? Oh, there's one special one here. What word means divided by 2?
Say hi.
Yeah, half. Right? Just like twice means multiply by 2. Because these are things we do a lot, half has its own name, means divide by 2, okay? This is enough for now. We're just going to start on this worksheet. We'll do a bunch of these together, and then you guys are going to do some on your own. Oops. Can I erase this stuff that we put up here? All right. So look at exercise 1A. I'm gonna use a different one. Write a calculation and a result that represents a number that is 5 greater than 3. Now, I want you to get in the habit of when you see 5 greater than 3, that means you're starting out at 3 and you're going up 5, right?
Yeah.
So, how would I write that?
3 plus 5.
Good. And it said write the result. So what's the result? Okay? Right, if you just have numbers, you can actually write what it's equal to. Now, you could say, like, well, can I put 5 plus 3? Yes, you could. But if you get in the habit of doing it like this, you won't have to remember that subtraction is different, okay? If you remember, if whenever they say, like, bigger than or diminished by, right, start with the number,
That's greater. Put
like the
5.
second number they tell you, put that first, kind of, right? Okay? B says, write a calculation and a result that represents a number that is 2 less than 9. Good. See, here it was important that you flip the order, right? Because otherwise you'd have 2 minus 9, that's negative 7. That's not what we wanted. All right. Write a calculation and a result that represents the sum of negative 3 and 8. So sum is which operation?
Addition.
Which gives you a 5.
Is it 5?
D, write a calculation and result that represents the difference of 20 and 12. Difference is which operation?
Subtraction.
Subtraction. So now, here you actually don't have to flip the order. It's only when they say less than. So 20 take away 12 is equal to
8.
Now notice, those ones were pretty easy, like there are no variables there, right? Once we get up to E now, we're going to start working with variables, which is really what we're going to be doing more of, right? If X represents a number, write an expression that represents a number 10 greater than X.
Plus 10.
Good, X plus 10, that's it. Right? We can't give a result here because you have a variable, okay? If N represents a number, write an expression that represents a number that is 5 less than N. Yeah, good. Now it starts getting a little bit more interesting, right? They start getting a little bit more complicated. If Y represents a number, write an expression that represents the sum of Y and the number 1 greater than Y. So we have sum. Which operation is it?
So that would be y plus 1. Y plus 1.
Yeah, exactly right. It's the sum of a number and the number that's 1 bigger than that number. So here's your number. What number is 1 bigger than Y? Y plus 1. And it's the sum of them, right? If we wanted to simplify that now, how can we simplify that? Not Y2,
2y.
2Y. 1y plus 1y is 2y. So you could say it's 2y plus 1, okay? Good. And H says, if n represents a number, write an expression that represents the difference between a number 1 larger than n and 1 smaller than n. Well,
Same thing, N2 and 2 and 1.
well, first of all, let's look at the first part. It says the difference is what operation?
Subtraction.
So we know we're going to be subtracting something, right? So the difference between a number 1 larger than n.
Would be 6.
What's 1 larger than n?
0.
No.
1 in.
N plus 1.
N plus 1. Yeah. 1 larger than n is n plus 1. The difference between that and the number that's 1 smaller than n.
Take away.
Give me the whole thing.
Take away n.
Huh?
Does that take away n?
No?
N minus 1.
N minus 1. All right, good. Now, there's only one problem here.
Okay.
We have to add something here. Actually, let me fix this.
Like term.
No, not like terms. I mean, we could do that, but before we do that, we're subtracting this thing from this thing, right? But the way it's written right now, the minus is only applying to that n. We want it to apply to this whole thing. So what do I add? Huh? Parentheses. Excellent. Good.
So
You have to do that.
The difference.
Yeah, because otherwise, you see, like when you distribute this negative, that's going to become minus n, but that becomes plus 1. If you don't do that, then it doesn't quite work out, okay? You could put if you want, you could put parentheses there, because we're subtracting this thing from that thing, but it doesn't really matter here because there's nothing in front. It's important here, okay? That's the one little tricky thing about that one. So far, so good? Can I erase? So they start getting a little bit more complicated now, but you know, hopefully we're just going to build upon the base that we started. Why am I looking at this? Okay, exercise 2A, right? Write an expression for a number that is 5 times greater than 2. Yeah, this one is a weird one. What number is 5 times greater than 2?
That'd be
5x plus 2.
Not 5x plus 2, that's different.
X
X times 5.
times.
Forget about the algebra right now. If I just said to you, what number is 5 times bigger than 2? 10. What did you do with those two numbers? That's what you got to do. Even though it says greater than here, the only thing that makes sense here is, let me see if I get my order right here. 5 times greater than 2. I think I would just write it like this.
Yeah, 5 times 2. That's what I said.
That's the only thing that makes sense. And evaluate the expression if it's numerical. Well, we can evaluate this, right? Because we don't have any variables. That one was a little confusing because of the greater than. Like, I had to think about it a little bit myself. Ms. Deepa, you also thought it was like phrased a little oddly, right? I agree. It's not the best. You know, on a Regents or something, they probably wouldn't give you that because it's a little, what's the word?
Yeah, they've been getting confused with it too. Like,
It's not a reliable question.
Yeah, there's a word that I'm trying to think of, but whatever. It's not exact enough. Let's say it that way. All right, B says, write a calculation and a result that represents a number that is 2 less than 9. Oh, wait, we already did that one. B, we're doing 2B. If n represents a number, then write an expression for a number that is twice n.
2n?
Yeah, 2n. Good. Simple enough. Write an expression for the quotient or ratio of 12 and 3.
So division.
12 divided by 3 or 12 over 3. And what does that equal?
4.
4. Good. Right? It said if it's numerical, you can give the answer. If x represents a number, write an expression for the ratio of x to 5.
X divided by 5.
Yeah, good. X divided by 5. Can I put equal something there? Can I say what this equal to? No, because we got a variable, right? Oh, now we're up to exercise 3, right? Let me get rid of this. You all got this?
Yeah.
Okay, 3A. You know what? Let me do this again. I'm going to put this up on the screen just to show you like the easiest way. Well, the trick is, and I don't know if it's a trick really, but the sort of the most logical way to do this stuff is, I always say, define your x first, okay? So they're saying if x represents a number, well, they're not saying anything. They're just saying we're going to use x. Write an expression for a number that is 3 more than twice the value of x. So you notice the x is all the way back here? We're going to go to there, and we're going to, thank you. We're going to work backwards from there. So it says twice the value of x. 2x, good. Now keep going backwards. 3 more than that.
Plus 3.
Thank you. We're going to work backwards from there. So it says twice the value of x. 2x, good. Now keep going backwards. 3 more than that.
Plus 3.
That's it. You're going to find that that's the easiest way to do this stuff, okay? Find your x and kind of either work outwards from there or backwards from there. If n represents a number, then write an expression for 2 less than 1/4 of n. Well, same thing. We got the n all the way in the back. Let's go backwards. How do I write 1/4 of n?
1/4.
Well, there's actually 2 ways to do it. That's one way. N over 4. What's the other way to write 1/4 n? Yeah, good. Just the way it sounds, right? 1/4 n. Those are both the same thing, right? And it's 2 less than that.
So take away 2.
Take away 2, right? Whichever one you use. It's like there's no, like, this isn't necessarily better than that. Whichever one you're more comfortable with is fine. Okay?
Oh, thank you. Thank you.
Hey, I feel like victorious. Okay. If S represents Sally's age, and her father is 4 years less than 5 times her age, write an expression for her father's age in terms of variable S. So we're going to use S. And what does S represent?
Sally's.
Good. So we have Sally's age.
Her father's 4
4 years less than 5 times her age. Her age is the S, right? So 5 times her age. 5S. Keep going. 4 years less than that. That's it. All right, does anybody want to try this one? If x represents a number, then write an expression for 3 times the sum of x and 10.
So
3x less than.
Anybody disagree? There's one thing we're missing here, actually.
multiplication.
No, you have the multiplication here, right?
The sum addition.
Yeah.
Right.
We have that.
Good, but it's this.
And 10?
Well, it says the sum of x and 10. It's 3 times that, right? Where's the sum of x and 10 here? The x plus 10. What's getting multiplied by the 3? Only the x. You want to multiply it by both of this whole thing. So what do I have to do? That's important, okay? So, because otherwise you're just multiplying the 3 times the x. You have to multiply it by this whole thing, x plus 10, okay? It's distributive property, yeah. Okay. If n represents a number, then write an expression for 7 less than 4 times the difference of n and 5, all right? Here's your n back here. Go backwards.
Difference is subtract
Right.
4 times.
Well, first, the difference of what?
N minus 5.
N minus 5. Keep going backwards. 4 times that.
Parentheses.
Very good. Parentheses with the 4. Keep going backwards. 7 less than this.
Take away.
You got to put it at the end, minus 7. Perfect. Right, remember with a less than? I said, you know, you usually, well, actually, if you do it this way, it kind of naturally, it goes in that direction. If you work backwards like that, it ends up writing itself down, okay? Nice. If x represents a number, then write an expression for the ratio of 3 less than x to 2 more than x. So ratio is what operation? So we're going to be dividing something.
X more than
3 less than x. How do you write it?
the X equals
Well, x minus 3,
Both of you got it. To 2 more than x.
two plus
2,
X.
yeah, 2 plus.
I'm going to put x plus 2, but yeah, you could put 2 plus x, okay? I'm just trying to get in the habit of you guys doing it this way, but if you put 2 plus x, it works.
And the ratio is division.
Right. So it's essentially a ratio, so think of it as a fraction, okay? If x represents a number, then write an expression for the sum of twice x with twice a number 1 larger than x. So you know, it sounds confusing. We're going to pull this stuff apart. Let's see, write an expression for the sum of, yeah, there's going to be addition in there. The sum of twice x
2x.
with twice a number 1 larger than x. Well, here's our x.
2x is twice the number, which is the number's X.
But what's 1 number larger than x?
3.
If x is 2, yeah, but we don't know.
Well, you said a number.
If the number is x, what's 1 bigger than x?
2.
X plus 1, right? But we have to multiply this times that whole thing. So I have to use parentheses, I think. Let's see. Write an expression for the sum of twice x with twice a number 1. Oh, yeah, that works. You could then distribute if you want, then you can combine like terms actually. We won't bother for this, but, well, you know what, let's just look at it. If we distribute this 2, we're going to get 2x plus 2x plus 2. And what's 2x plus 2x? So you could say it's 4x plus 2. That's like a little bit simplified, right? But you can't get there from here. You have to go to that step first. But if they said to simplify, you do that, but otherwise you can just leave it like that. If n represents a number, then write an expression for the quotient of twice n with 3 less than n.
2n minus 3.
I heard 2n.
2n.
Division.
It's division. The quotient of twice n with 3 less than n.
So minus 3n. And minus 3.
N take away 3, yes. Let me erase and scroll up. Actually scroll up. We're up to I, right? Perfect. If y represents a number, then write an expression for 3/4 of the difference of y and a.
Quarters is division.
Quotient?
Quarters. The 3/4.
Oh, no. 3/4 is a fraction. How do you write
Yeah.
3/4? Huh?
3.
How do you write 3/4? 3/4. 3/4 of the difference of y and a.
So
Difference
minus.
of fraction.
Okay, but tell me the exact thing correct.
So y minus y.
Y minus a.
Oh, y minus.
And now, how do I put that 3/4 here? What do I do?
Parentheses.
Parentheses, good. Because it's 3/4 of that whole thing, okay? Another way that you could write that, not that it's that big a deal, but it's the same as this. I think that makes more sense, though, okay? If x represents a number, then write an expression for 1/2 the sum of x and 4. That's not good. So, how do you write the sum of x and 4?
Well, X plus 4.
Good. Now it's 1/2 of that.
Parentheses 1/2.
Good. Parentheses 1/2. Or another way to write that is x plus 4 over 2. Same thing. I'm going to let you do this last one here. Let's see, you add a number to one less than and one more than the number. So let's say if x is 3, 1 more than 3 would be 4, and 1 less than 3 would be 2, and we get what? 7 and 2 is 9. 5 plus 4 plus 6 is 15. Think of 2 other numbers, write it in there, and see what the pattern is. Think of your own number, and then add that number to one number less than that, plus one number bigger than that. So just think of a number, and then add it to one less than that number.
You mean one more than that number, then one less than that?
Yes. So you're adding 3 numbers. The number, and then whatever is 1 less than that number, and then add that to 1 more than that.
15.
Oh, sorry about that. So put your other in here, and you should see that something happens. Like there's a pattern that's going to show itself.
They tell you the translate, right? What would be like that? So you just pick another number and just do whatever you do. You have time.